Hello, in this lesson, I want you to determine intervals in which functions are increasing, constant, or decreasing and determine the maximum and minimum values of the functions. I want you to determine the average rate of change of a function. So we have some vocabulary words here again. We have increasing, decreasing, constant, maximum, minimum, extrema, average rate of change, and secant line. When a function is increasing, it's rising from left to right. That's what increasing means. When it's decreasing, it's falling from left to right. When it's constant, it's not changing in either direction. So if we take a look at an example here, I want to use the graph of the function to estimate the intervals to the nearest half a unit, so which the function is increasing, decreasing, or constant. I want to support my answer numerically. So if I look at this parabola here, it looks like it's decreasing because it's falling. I'm going to go from negative infinity to 0. So I'm going to say this function is decreasing. When is it decreasing? Well, it's decreasing from negative infinity to 0. Now, you're always going to use parentheses when with increasing and decreasing because a function is increasing or decreasing over an interval, not at a certain point. So it'll never be at this point. Then if we take a look here, it's increasing from 0 to positive infinity. Now, what I want to do is I want to support this numerically. So what I'm going to do is I'm going to make a table for my graph. So my table, let's go into Desmos. I think that's the easiest way to explain it. And I'm going to go to a new blank graph. And what I'm going to do is I'm going to make a table for this function. And I'm going to look at when is it increasing, when is it decreasing. So if I press the plus sign, I'm going to make a table here. My direction is set to the nearest half unit. So if I look at my graph, I could start any place I want. I think I'm going to start at negative 3. And I'm going to go up by a half. So my next one, I'm going to go negative 2.5. Then the calculator is smart because after I do the first couple, as long as they're the same, it automatically fills that in. I'm going to go all the way up to 3. I could go more, I could go less, but 3 seems like a good point for me. Now what I'm going to do is I'm going to type in my function. Now notice my variable is x1. For some reason in the table, they like to use x1 for your variable rather than just x. So what I'm going to do here is in my second column, I'm going to erase that y. I'm going to type in my function, which is x1 squared. So I'm going to go x1 squared, and I'll go minus 4. Now I just look at my table. When you start at negative 3 to negative 2.5, it goes 5 to 2.25, so it's falling. It's falling after when you get to 0. Keeps on falling, falling. When I get to negative 3.75, negative 4. Now, notice you're at 0. Then it starts rising again. So we were doing that right. Let's take a look at another one here. Now, we got a little bit more going on here, don't we? So I definitely see, I always have to go left to right. So it's decreasing from negative infinity to looks like about a half, right? So I'm going to say it's decreasing from negative infinity to 1/2. Then it starts increasing from, well, it should be negative 1/2, sorry about that, from negative 1/2 to 1/2. And then it starts falling again, doesn't it? So then it's decreasing again from 1/2 to positive infinity. Now what I've done to save us some time, I've actually made this table already. So let me see if I can open this up. So here is my table. If it'll open, there we go. So notice I start at negative 3, 24 to 13, I'm falling. 13 to 6, I'm falling. 6 to 1.875, I'm falling. I'm falling to 0, falling to negative 3.7. Okay, right there, that's where I stop at. So negative 1/2 was a good guess. And then it starts at negative 3.75, then it goes up to 3.75, then it starts falling again. So it's increasing from negative 1/2 to positive 1/2. We can see that. And then it starts falling again. And so, in other words, we notice our table supported a graph. When you do this in work, you just draw your table out and copy the table down into your notebook.